Students, in lesson 1.4, Algebra, we are going to be working with powers of 10 and exponents. Our essential question that will frame our learning for this lesson is, how can you use an exponent to show powers of 10? So for this lesson, our purpose is showing powers of 10 and using exponents. We're going to start with the unlock the problem. Expressions with repeated factors, such as 10 times 10 times 10, can be written by using a base with an exponent. The base is the number that is used as the repeated factor, and the exponent is the number that tells how many times the base is used as a factor. So what we see is we have the factor 10 repeated 3 times. What we can do is we can write the base of 10, which was the number that we repeated 3 times, and the amount of times, which is the exponent, was 3, and then we could solve that, and the answer would be 1,000. We could say this in word form, the third power of 10, or an exponent, the third power of 10. So what we're going to use is we're going to explore thousands, which is this large cube. And when we explore thousands, we're going to use the T in a box for 1,000. So in our activity, we're going to use our base 10 blocks. It says, what is 10 times 1,000 written with an exponent? So what we can see is that 1 written as an exponent is the 0 power of 10. A 10, or 10 ones, is written as 1 times 10, or the first power of 10 in exponent form. 100 ones is written as 1 times 10 times 10, or in exponent form, the second power of 10. And 1,000 ones is written as 1 times 10 times 10 times 10, or as an exponent form, the third power of 10. So our first question, it says, how many ones are inside of 1? So we look at our 1, and we see that there is 1 inside of 1. Next, we move on to our next question. How many ones are inside of 10? So we look at our 10, and we know that there are 10 inside of there. There are 10 ones inside. Next, how many 10s are in 100? We look at 100, and we think to ourselves, it's asking about 10s. We know this is representative of 10, so we know we can count how many 10s are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 10s inside of 100. And it says to us, to remind us, think 10 groups of 10, or 10 times 10, which would give us 100 ones. Next, how many hundreds are in 1,000? So we're in 1,000, and we're going back to the previous model of hundreds. How many of those are inside? Well, we know that this is a three-dimensional cube, and we know that there are 10 sets of 10 sets of 100 in 1,000. Next, it says, how many thousands are in 10,000? So we know that there would be 10 sets of thousands, which is representative of this last drawing, inside of 10,000. So it says, in the box at the right, draw a quick picture to show 10,000. So we know that there are 10 sets. This is one set. We're going to draw 10 of them. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have represented 10,000 ones, or 1 times 10 times 10 times 10 times 10. Now we know the repeated factor is 10. Let's count how many times it's repeated. 1, 2, 3, 4. So we know that the exponent would be 4. So in exponent form, we would say that this is the fourth power of 10. And when we would evaluate that, we would get 10,000. So we're going to go on to our next part of our activity, which we're going to be dealing with a different example before we expand our ideas about representing powers of 10 and exponents. So in this example, it says, multiply a whole number by a power of 10. Hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster its wings beat. The average hummingbird beats its wings about 3 times the third power of 10 times a minute. How many times a minute is that written as a whole number? So what we can do is we can multiply 3 by powers of 10 and look for a pattern. So the 0 power of 10 is 1, so 3 times 1 would be 3. We know that 3 times the first power of 10, if we evaluate the first power of 10, we know that's 10. So 3 times 10 would be 30. Next, we know that 3 times the second power of 10 is really like saying 3 times 10 times 10, because the second power of 10 is just a different way that we can express 10 times 10. So 3 times 10 times 10 would give us 300. And lastly, 3 times the third power of 10. We know that when we evaluate 3, the third power of 10, it's really 10 times 10 times 10, which would give us 1,000. And 1,000 times 3 would be 3,000. So the average hummingbird beats its wings about 3,000 times a minute. So this math practices here, we're going to do this in class, but what it says is, explain how using exponent simplifies an expression. It also asks us, as part of our mathematical practices today, students, to look for a pattern, and what pattern do we see? So what we might be able to say is, for each power of 10, the number of zeros written after the whole number is the same as the number in the exponent. So this whole lesson, students, is about patterns and identifying the powers of 10 and exponents. So it might be a good idea in your list of notes to make a powers of 10 chart. And remember again, the 0 power of 10 is 1. The first power of 10 is 10, because really it's like saying 10 times 1. The second power of 10 is really like saying 10 times 10, which is equal to 100. And the third power of 10 is really like saying 10 times 10 times 10, which would be equal to 1,000. So it's important to study and identify these patterns, because it'll make it a lot easier when you're trying to represent powers of 10s and exponents. Be sure to take really good notes in your notebook and draw out the diagrams that we practiced throughout this lesson.